Hi, I'm Dallas, and I'm here to tell you guys all about the mole. I'm going to expose all its secrets. So first question is, what is a mole? Well, a mole is a chemical formula unit used to measure various things. A mole is equal to 6.02 times 10 to the 23rd power. This is written in scientific notation to make sure you don't have to have a bunch of zeros. A mole is also equal to molar mass, which is the mass of multiple elements put together. And then a mole is also equal to 22.4 liters. Particles includes atoms, ions, molecules, and formula units. An example of this is a chemical equation of glucose, and this is also a balanced equation since all parts of the energy are equal on both sides. So glucose formula, there are the reactants over here, 6CO2 plus 6H2O equals 6C6H12O6, which is a molecule of glucose. These are the products over here. Now that you know what a mole equals, you can use the mole conversion. You can convert moles to mass and moles to gas. So moles to particles. The final conversion thing you can do is you can do particle to gram, which is a 3-step problem. Now that you know all these conversion factors, you can use them in the next particular formula, empirical formula, and the percent composition.
Hi, I'm Payton, and the 3 formulas you need to know are chemical composition, empirical formula, and molecular formulas. They all bounce off of each other, and the very first one you need to know is the percent composition. So it basically describes the chemical composition of a compound. And so step 1, you need to find the mass of each element. So you can look at that by looking at the periodic table, and then the number under the element is its mass. So you find the total mass of the compound. So down here we have Ca, S, and O. There's one Ca, so it's 40.08 grams. And then you have one S, which is 32.07. And then you have 4 oxygens. So you multiply 4 times the atomic mass, which is 16.00, and you get 64.00. And then you determine the percents like this. You take the mass of the individual elements. So you take 40.08, 32.07, and 64.00, and you divide them by the total mass of the compound, which is 136.15. So you divide all of those, and then you multiply them by 100. Whatever you get at the end is the percent of that element. So like for Ca, 29.44% of it is used in the percent composition, and then for S it's 23.55%, and in O it's 47.01%. You know this is correct once all percents add up to 100.
I'm Bree, and I'm here to talk about the second formula you need to know. The empirical formula is a simple formula of a substance. And so we're going to start with this question. What is the empirical formula of a compound that contains 40% sulfur and 60% oxygen? So step 1, what we're going to do is convert the percents into grams. And once we do that, step 2, you're going to do the dimensional analysis, and you're going to put the 40 grams here, and then 1 mole here, and then you're going to take the mass of sulfur off the periodic table, and you're going to put it in this bottom one right here. And what you're going to do is you're going to multiply this by this, and then divide it by that, and you get 1.25 moles of sulfur. And you do it with the oxygen as well. You take the 60 grams in here, the mole, and you put it in here, and then the mass at the bottom. And you do the same step here, multiply this by this, and then divide it by the mass, and you get 3.75. And then the next step, what you're going to do is take the smallest amount of moles, which is 1.25, and you're going to take the smallest amount, and then you're going to divide it by itself, and you get 1. Then divide it by oxygen, and you get 3. And what this means is there is 1 sulfur and 3 oxygens. Therefore, the formula is SO3.
I'll be talking to you about the last formula that you need to know. This is the molecular formula. This is basically the actual formula for the substance. And if this is your question, what is the molecular formula of the compound that contains 92.3% carbon and 7.7% hydrogen and a mass of 26 grams? Alright, so what we're going to start off with is dimensional analysis. We're going to set it up with your percent that was given for the carbon, so we're working on carbon. So 92.3 grams, because you change your percent to grams, with 1 mole of carbon. Now 1 mole of carbon is equal to the 12.01 grams of carbon, and that is actually the atomic mass of carbon from the periodic table. So when you multiply this, it's going to equal 92.3. it's just 1. And then you're going to divide 92.3 by 12.01. And you're going to get 7.7. You're going to do the exact same dimensional analysis down here with your 7.7 for hydrogen. So 7.7 grams of hydrogen times 1 mole of hydrogen is going to equal 7.7, and then you're going to divide it by 1.01. And then you're going to get 7.7 moles of hydrogen. So they're both the same. Now you're going to come down here and say, oh, which one's the smallest? But these are the same, so it's just 7.7. Now you're going to have your carbon, 7.7, divided by 7.7, and it's going to equal 1. So overall, your empirical formula is going to be CH. So now you're going to use your 26 grams from the question, and you're going to put it down here with the amount that is the mass of CH. So it's 26 divided by 13 equals 2. So now you're going to take your CH and multiply it by 2. So this empirical formula gives you your molecular formula of C2H2.